Imagine the Combat Information Center deep inside a People's Liberation Army Navy, Clan, Type 055 guided missile cruiser. It is the pride of the Chinese fleet, a 13,000-ton Leviathan bristling with 112 vertical launch cells, patrolling the contested, politically explosive waters of the Philippine Sea. The geopolitical temperature has reached the boiling point. A conflict has erupted, and the Chinese fleet has established a massive, overlapping anti-access/area denial (A2/AD) shield, projecting a dome of impenetrable radar and surface-to-air missiles for hundreds of miles in every direction. The radar operators are tense. They are scanning the horizon for the traditional, recognizable threats of the American war machine. They are looking for the distinct, massive radar cross-section of AB-52 Stratofortress. They are looking for the swept-wing profile of AB-1B Lancer. They are desperately trying to isolate the faint, ghostly returns of AB-2 Spirit stealth bomber. But their screens are relatively clear of strike assets. The only American aircraft operating at the very edge of their 500-mile radar horizon is a solitary, massive, slow-moving blip. The computers instantly classify the contact based on its size, speed, and altitude profile. It is a Boeing C-17 Globemaster III, a heavy military transport plane. To the Chinese commander, a C-17 is a logistical asset. It is a flying moving van. It is a target that carries troops, medical supplies, or spare parts. It does not carry anti-ship missiles. It is not a kinetic threat. The commander assesses that the American transport is simply executing a resupply run to a distant base in Guam or Australia, desperately trying to stay outside the engagement envelope of the Chinese HQ-9 surface-to-air missiles. The commander dismisses the contact and orders his operators to keep searching for the bombers. That single, arrogant assumption is a fatal mistake. It is the last mistake the Chinese commander will ever make. Because 500 miles away, inside the cavernous, unpressurized cargo hold of that C-17 Globemaster, there are no troops. There are no medical supplies. The loadmasters are standing next to a massive, imposing steel cage strapped to airdrop rollers. A green light flashes in the cargo hold. The massive rear ramp of the C-17 lowers, exposing the freezing, thin air of the stratosphere. The loadmaster pulls a release lever. The massive steel cage, weighing tens of thousands of pounds, rolls smoothly off the ramp and plunges into the sky. To the Chinese radar operators, the single, slow-moving blip on their screen hasn't changed. But suddenly, 36 new, incredibly faint, highly maneuverable contacts materialize out of thin air, dropping below the radar horizon, skimming the wave tops, and accelerating toward the Chinese fleet at terrifying speed. The C-17 wasn't delivering cargo. It was delivering a swarm. The Chinese fleet has just fallen victim to the most brilliant, ruthless, and asymmetrical technological hack in the history of the United States Air Force. They have just been annihilated by Project Rapid Dragon. Welcome to Doctrine of War. Today we are executing a forensic, deep-dive tactical analysis into the most lethal, paradigm-shifting weapon system you have never seen in a Hollywood movie. Here is the thesis for this episode. In modern, high-intensity, peer-to-peer warfare, the side that wins is not necessarily the side with the most exquisite, billion-dollar stealth technology. The side that wins is the side that can put the highest volume of high-explosive ordnance onto the enemy's forehead in the shortest amount of time. It is the brutal, unforgiving mathematics of saturation. And when the United States Air Force realized they did not have enough bombers to solve that math equation, they decided to turn their logistics fleet into the deadliest armada of flying missile cruisers the world has ever seen. If you are beginning to understand why the true balance of global power is no longer decided by who has the sleekest fighter jets, but by who can master the dark arts of payload delivery, electronic deception, and overwhelming, attritable mass, hit that like button and subscribe to Doctrine of War. We strip away the political spin, the defense contractor brochures, and the diplomatic pleasantries to bring you the cold, kinetic realities of how the free world actually fights, hacks its own hardware, and deters its adversaries. Your support ensures we can keep delivering this level of uncompromising strategic analysis. For decades, the global deterrence strategy of the United States relied on the bomber mafia, the elite, highly centralized fleet of B-52s, B-1s, and B-2s. But as the Chinese military poured trillions of dollars into building the most dense, highly capable air defense network on the planet, the math of the bomber fleet stopped working. We are going to break down the math of saturation. Why sending 2 bombers to attack a Chinese fleet is a suicide mission, and why volume is the only true armor. We are going to expose this smart pallet kill chain, the staggering, highly complex mechanical and software engineering required to drop a live, fueled cruise missile out of a cargo plane and actually make it fly. We will analyze the radar nightmare, the absolute strategic ambiguity that forces enemy commanders to play a lethal shell game, guessing which cargo plane is carrying toilet paper and which one is carrying Armageddon. And finally, we will look at the logistics of lethality, how Agile Combat Employment, ACE, allows the US Air Force to launch strategic strikes from dirt strips in the jungle, completely bypassing the vulnerability of massive concrete megabases. Let us begin by looking at the terrifying numbers that forced the Pentagon to realize their traditional bomber fleet was utterly insufficient for a Pacific war. The A2/AD Shield and the death of the Silver Bullet. To truly appreciate the absolute, desperate necessity of Project Rapid Dragon, you must first understand the catastrophic mathematical problem facing the United States Air Force in the Indo-Pacific theater. Since the end of the Cold War, the United States has fought wars against technologically inferior adversaries: Iraq, Afghanistan, Serbia, Libya. In these conflicts, the US enjoyed absolute uncontested air supremacy. A single B-2 Spirit stealth bomber could fly over a target, drop a handful of precision-guided joint direct attack munitions, DAMs, and obliterate the objective with near-total impunity. We became addicted to the concept of the silver bullet, the idea that a small number of exquisite, hyper-expensive, perfectly accurate weapons could win a war. The People's Republic of China studied this American way of war, and they spent the last 30 years explicitly building an architecture designed to render it obsolete. They built the Anti-Access/Area Denial, A2/AD Shield. This is not a single weapon. It is a massive, overlapping multi-domain network of lethality. It consists of highly advanced long-range surface-to-air missiles, SAMs, like the HQ-9 and the Russian-supplied S-400, stationed along the Chinese coastline and on artificial islands in the South China Sea. It includes a massive fleet of J-20 stealth fighters and KJ-500 airborne early warning aircraft patrolling the skies. And crucially, it includes a massive surface fleet of Type 055 cruisers and Type 052D destroyers, each packing dozens of vertical launch cells filled with interceptor missiles. If you fly a small flight of American fighter jets or bombers into this A2/AD Shield, you are not engaging in a tactical strike. You are committing mathematical suicide. If a pair of B-1B Lancer bombers attempts to attack a Chinese carrier strike group in the Philippine Sea, they might be able to launch a volley of 48 long-range anti-ship missiles, RASMs. In a vacuum, 48 advanced cruise missiles sounds like an overwhelming, apocalyptic strike. But against a modern layered Chinese naval defense grid, it is simply not enough. The Chinese destroyers will utilize their massive active electronically scanned array, ASA, radars to detect the incoming missiles. They will launch their own combat air patrol fighters to intercept them. They will ripple-fire dozens of HQ-9 interceptor missiles. They will activate massive electronic warfare jammers to blind the American missile seekers. And finally, their close-in weapon systems, CIWS, will throw up a wall of tungsten at 4,000 rounds per minute to shred any surviving missiles in the terminal phase. To guarantee the destruction of a high-value Chinese naval asset, military logisticians calculate that you cannot fire 40 missiles. You must fire a saturation swarm. You must fire 100, 150, or even 200 missiles simultaneously from multiple different vectors to completely overwhelm the processing power of the Chinese combat computers and physically exhaust their magazines. You have to force the Chinese ships to shoot all of their interceptors. Once their vertical launch cells are empty, they are defenseless. But to achieve that magazine depletion, you need to put an unfathomable volume of fire into the air on day one of the conflict. The bomber bottleneck. And this is where the United States Air Force hit a terrifying, immovable brick wall. They simply do not possess enough bombers to carry that many missiles. Let us look at the inventory. The crown jewel of the American Strategic Bomber Force is the B-2 Spirit stealth bomber. It is a masterpiece of aviation engineering, invisible to radar, capable of penetrating deep into enemy airspace. But the United States only built 21 of them. Over the decades, a few have been lost to accidents. Today, the operational fleet hovers around 19 airframes. Because the B-2 requires highly specialized, climate-controlled hangars to maintain its delicate radar-absorbent coating, and because it requires hundreds of hours of maintenance for every single hour of flight time, the actual ready-to-fly availability rate of the B-2 fleet is notoriously low. On any given day, the U.S. Air Force might only be able to generate 5 or 6 combat-ready B-2s for an immediate strike in the Pacific. Even if you load those few B-2s to their absolute maximum capacity with JASSM-ER, Joint Air-to-Surface Standoff Missile Extended Range, cruise missiles, you are only putting a few dozen missiles into the air. What about the B-1B Lancer? The Bone is a supersonic heavy payload beast, capable of carrying 24 JASSMs internally. But the B-1B fleet is aging rapidly. It was flown into the ground providing close air support during the global war on terror in the Middle East. The airframes are stressed, and the fleet is shrinking as the Air Force retires older models to harvest them for spare parts. What about the legendary B-52 Stratofortress? The Buff can carry a massive payload of cruise missiles on external pylons. But the B-52 is a 60-year-old airframe with the radar cross-section of a barn. It cannot survive anywhere near contested airspace. It must launch its cruise missiles from thousands of miles away, making it a predictable, heavily tracked asset. The Air Force is building the new B-21 Raider stealth bomber to solve this problem. But building a fleet of 100 next-generation stealth bombers takes decades. The first B-21s won't be available in significant, combat-credible numbers until the 2030s. The strategic planners in the Pentagon realized they had a massive, glaring gap in their capability right now, in the most dangerous decade of the 21st century. The Davidson window, the period between 2025 and 2030 where China's military advantage over Taiwan peaks, was wide open, and the US Air Force did not have the magazine depth to close it. They needed a way to put thousands of cruise missiles into the air simultaneously, without spending $1 trillion and waiting 20 years for new stealth bombers. They needed a hack. They needed a paradigm shift. They looked away from the elite, highly classified hangars of the bomber mafia, and they looked toward the gritty, unglamorous, diesel-soaked tarmac of the Air Mobility Command. They looked at the cargo planes, the genesis of the flying magazine. The concept of throwing bombs out the back of a cargo plane is not entirely new. During the Vietnam War and the Gulf War, the U.S. military used C-130 Hercules transport planes to drop the massive Blue 82 Daisy Cutter and the GBU-43/B Moab, mother of all bombs. But those were essentially massive, dumb gravity bombs. They were pushed out the back of a plane, deployed a parachute, and fell straight down to clear jungle landing zones or collapsed cave complexes. You cannot do that with a modern, high-tech cruise missile. A cruise missile like the AGM-158B JASSM-ER is a highly sensitive, incredibly complex flying robot. It has fragile deployment wings, a delicate turbofan engine, and a highly calibrated internal navigation system. You cannot simply strap a JASSM to a wooden pallet, kick it out the back of a C-17 at 30,000 feet, and expect it to magically start flying. If the missile tumbles chaotically in the slipstream, the engine will not ignite. If the wings deploy at the wrong angle while the missile is spinning, they will shear off. To turn a cargo plane into a missile cruiser, the Air Force Research Laboratory, AFRL, working in conjunction with Lockheed Martin, had to engineer a flawless, automated, highly complex mechanical deployment sequence. They had to invent a way to safely, predictably, and reliably transition a cruise missile from a horizontal resting state inside a cargo hold to a vertical, stabilized, powered flight state in the middle of the freezing stratosphere. They invented the deployment box. And they called the entire system Project Rapid Dragon. The mechanics of the drop. Let us break down the exact, step-by-step mechanical kill chain of a Rapid Dragon deployment. It is a masterpiece of physics, aerodynamics, and software integration. The system relies on standard airdrop procedures that the Air Mobility Command has perfected over 70 years of dropping tanks, Humvees, and supplies. The Air Force uses existing, unmodified C-130 Hercules and C-17 Globemaster 3 cargo planes. They do not need to cut holes in the fuselage. They do not need to install complex launch rails or hydraulic ejection seats. The Rapid Dragon system is a massive, self-contained steel framework, a deployment box, that is mounted on standard wooden and aluminum shipping pallets. Inside the steel cage, the JASSM-ER cruise missiles are stacked vertically, nose down. A C-130 Hercules can accommodate a 6-pack or a 12-pack deployment box. The massive C-17 Globemaster 3 can easily carry a 36-pack of cruise missiles. Before the aircraft even reaches the launch zone, the true magic of the system occurs inside the cargo hold. The Rapid Dragon deployment box is not a dumb piece of steel. It is a smart pallet. It features an onboard computerized battle management system. While the C-17 is flying toward the target area, the onboard battle management system receives updated real-time targeting coordinates via secure satellite uplinks from a forward-deployed F-35 stealth fighter or a naval destroyer. The Rapid Dragon system translates these coordinates and feeds them directly into the navigation computers of the 36 individual JASSM-ER missiles sitting inside the cage. Every single missile is assigned a specific target, a specific flight path, and a specific time-on-target synchronization. When the launch order is given, the cargo plane does not need to alter its flight profile or execute any dangerous combat maneuvers. It maintains a steady, level flight path high above the clouds. The loadmaster in the rear of the aircraft hits the deployment switch. First, a small drogue parachute is fired out the back ramp of the aircraft. This drogue chute catches the high-speed slipstream and acts as an aerodynamic anchor, violently pulling the massive, multi-ton steel deployment box along the floor rollers and out the rear ramp of the plane. As the massive steel cage plunges out of the aircraft and into freefall, a sequence of highly timed, explosive events occurs. The main parachutes deploy, blooming in the thin atmosphere. These massive parachutes are not designed to gently float the cage all the way down to the ocean. They are designed to act as an aerodynamic brake, violently decelerating the deployment box and critically stabilizing it. The parachutes force the steel cage to hang perfectly, plumb vertical in the sky. The chaotic tumbling stops. The steel deployment box has now become a mid-air vertical launch system, VLS, dangling under a parachute at 25,000 feet. Once the box is stabilized, the automated sequence inside the cage takes over. The missiles are not dropped all at once, which could cause them to collide in mid-air. They are released in a perfectly timed, staggered sequence. A pneumatic clamp releases. The first AGM-158B JASSM-ER cruise missile drops out of the bottom of the steel cage, nose first, like a dart falling from the sky. As the missile drops clear of the cage, its internal computers recognize that it is in freefall. Explosive bolts fire, and the missile's aerodynamic wings and tail fins snap open. The Williams International F-107 turbofan engine ingests the rushing air and ignites with a roar of combustion. The missile pulls out of its dive, levels off, and accelerates toward its target. A second later, the next missile drops out of the cage. Then the next. Then the next. Within a matter of seconds, the deployment box has emptied its entire payload of 36 stealthy cruise missiles into the sky. The empty steel cage and the parachutes are discarded, falling uselessly into the ocean below. The C-17 cargo plane, now thousands of pounds lighter, simply closes its rear ramp, banks away, and heads back to base to pick up another pallet. In the span of 2 minutes, a slow, unarmed logistical transport plane has just unleashed the equivalent firepower of 2 entire squadrons of B-1B Lancer bombers or a full Arleigh Burke-class guided missile destroyer. The math of saturation has been solved. The shell game of the Pacific. The mechanical brilliance of dropping missiles out of a cargo plane is undeniable. But the true devastating impact of Project Rapid Dragon lies not in the hardware, but in the psychological and electronic warfare terror it inflicts upon adversary air defense commanders. To understand why Rapid Dragon breaks the Chinese A2/AD doctrine, you must look at how an air defense network actually functions. When a Chinese radar operator sitting on a militarized artificial island in the South China Sea looks at their radar screen, they are looking for specific, identifiable signatures. Modern phased array radars and combat computers use complex algorithms to classify contacts based on their radar cross-section, RCS, their altitude, their speed, and their flight profile. If the radar detects a very small, incredibly fast contact flying at high altitude, the computer flags it as a potential fighter jet. If it detects a massive, fast-moving contact, it flags it as a bomber. The Chinese air defense network is heavily optimized, trained, and programmed to hunt for American B-1, B-2, and B-52 bombers. When they see a bomber profile on the screen, the threat level goes to red, interceptor missiles are armed, and combat air patrol fighters are scrambled. But what happens when the radar detects a massive, slow-moving, lumbering contact flying a steady, predictable path at 30,000 feet? The radar classifies it exactly as what it is: a heavy airlift cargo plane. AC-17 or AC-130. In a theater as massive as the Indo-Pacific, the United States Air Force Air Mobility Command operates hundreds of these flights every single week. They are the logistical bloodstream of the American military presence in Asia. They are flying from Hawaii to Guam, from Guam to Japan, from Japan to the Philippines and down to Australia. They are carrying troops, mail, spare parts for fighter jets, food and medical supplies. They are ubiquitous. They are background noise. Before Project Rapid Dragon, an adversary air defense commander could largely ignore these cargo flights. They were not a kinetic threat. Why waste a multi-million-dollar HQ-9 long-range surface-to-air missile shooting down AC-17 carrying a shipment of toilet paper and engine oil to Kadena Air Base? You conserve your highly valuable, finite interceptor missiles for the actual strike assets, the bombers and the fighter jets. Project Rapid Dragon completely, violently destroys that assumption. By turning the cargo fleet into the strike fleet, the United States Air Force has introduced the ultimate element of strategic ambiguity. The Chinese radar operator is now forced to play a lethal, impossible shell game. The cost exchange dilemma. When that blip of a C-17 appears on the edge of the Chinese radar horizon over the Philippine Sea, the Chinese commander is faced with an agonizing, paralyzing dilemma. Is that C-17 flying a routine logistical mission to resupply a Marine Corps base in Okinawa? Or is it carrying a 36-pack of Rapid Dragon JASSM-ER cruise missiles, flying to a launch point to decapitate the Chinese fleet? Because the C-17 looks exactly the same on radar regardless of what is in its cargo hold, the Chinese commander cannot tell the difference. If the commander chooses to ignore the C-17 assuming it is just a cargo flight, and it turns out to be a Rapid Dragon plane, the Chinese fleet will be annihilated by a massive, unexpected swarm of stealthy cruise missiles dropped from right under their noses. But if the Chinese commander assumes every C-17 is a Rapid Dragon threat, they must engage it. They must launch their long-range interceptor missiles or scramble their fighter jets to shoot down every single American cargo plane that enters their airspace. This triggers a catastrophic cost exchange ratio for Beijing. If China fires two $2 million HQ-9 surface-to-air missiles to shoot down a C-17, and the C-17 was only carrying pallets of MREs, meals ready to eat, and spare truck tires, the Chinese military has just wasted $4 million and two highly valuable, difficult-to-replace interceptor missiles on a decoy. The United States has hundreds of C-17s and C-130s. They can afford to flood the airspace with logistical flights, intentionally saturating the Chinese radar networks with massive, slow-moving targets. They can fly a dozen empty C-17s toward the Chinese fleet from the north, drawing all the attention and interceptor fire, while a single C-17 carrying the Rapid Dragon payload sneaks in from the south and drops the kill shot. Rapid Dragon forces the adversary to treat the entire logistical tail of the United States military as a Tier 1 frontline strike threat. It breaks their targeting calculus. It exhausts their magazines. It induces a level of paranoia and friction into the adversary's decision-making loop that makes defending the A2/AD shield practically impossible. The vulnerability of the megabase. The mechanical ingenuity of the palletized drop and the psychological warfare of the shell game are formidable, but the true grand strategic value of Project Rapid Dragon lies in its ability to completely rewrite the geography of power projection in the Pacific. It solves the most terrifying vulnerability of the American bomber fleet: the runway. Heavy strategic bombers are exquisite, high-maintenance machines. A B-2 Spirit stealth bomber or a B-52 Stratofortress cannot land just anywhere. They require massive, pristine 10,000-foot-long reinforced concrete runways. They require highly specialized, climate-controlled maintenance hangars, massive fuel depots, and extensive logistical support networks. In the entire Indo-Pacific theater, there are very few bases that can accommodate these bombers. Andersen Air Force Base in Guam, Diego Garcia in the Indian Ocean, and a handful of bases in Japan and northern Australia. This is a massive strategic liability. In the era of long-range precision ballistic missiles, fixed, massive concrete megabases are not sanctuaries. They are highly visible, deeply surveyed targets. The People's Liberation Army Rocket Force (PLARF) has spent decades building an arsenal of thousands of intermediate-range ballistic missiles, IRBMs, specifically designed to crater the runways of Guam and Okinawa in the opening hours of a conflict. If China destroys the runway at Andersen Air Force Base, the entire American bomber fleet is temporarily grounded. They cannot take off. They cannot land. They are removed from the fight, dispersing the arsenal. Project Rapid Dragon bypasses this vulnerability entirely by fundamentally changing the launch platform. The C-130 Hercules and the C-17 Globemaster III are not fragile, high-maintenance divas. They are rugged, durable, heavily reinforced tactical airlifters designed explicitly to operate in the most austere, unforgiving environments on the planet. A C-130 Hercules does not need a 10,000-foot pristine concrete runway. A C-130 can land on a 3,000-foot dirt strip in the middle of a jungle. It can land on a frozen lake. It can land on a straight stretch of civilian highway in the Australian outback. The C-17, despite its massive size, is famously capable of short-field landings on unpaved surfaces, utilizing its powerful thrust reversers to stop in an incredibly short distance. By putting the strike capability of a heavy bomber into the cargo hold of a tactical airlifter, the United States Air Force has executed the ultimate manifestation of Agile Combat Employment, ACE. The ACE doctrine dictates that you do not concentrate your forces on massive, vulnerable megabases. You disperse them. You scatter them across a vast, unpredictable network of remote islands, civilian airports, and austere dirt strips. With Rapid Dragon, the launch points for a devastating American cruise missile strike are no longer limited to Guam or Hawaii. A squadron of C-130s loaded with Rapid Dragon pallets can launch from a dirt runway on a tiny, remote island in the Philippine archipelago. They can stage out of an abandoned World War II airstrip in the Solomon Islands. They can launch from the vast, sprawling network of civilian highways in the Australian Northern Territory. They can land, refuel from a hidden fuel bladder, load the missile pallets, and take off again in a matter of hours, completely disappearing before Chinese spy satellites can even register their presence, let alone target them with ballistic missiles. This geographic dispersal creates an insurmountable targeting nightmare for Beijing. The PLA rocket force cannot possibly target every single dirt strip, every single highway, and every single civilian airport across the millions of square miles of the first and second island chains. By utilizing the C-130 and the C-17, Project Rapid Dragon transforms the entire geography of the Indo-Pacific from a vulnerability into a weapon. It democratizes strike warfare, ensuring that the United States can launch a devastating, massed missile swarm from literally thousands of untrackable, indestructible locations. Conclusion. Project Rapid Dragon is a masterpiece of asymmetrical warfare. It is the ultimate low-tech hack applied to a high-tech problem. For decades, the military-industrial complex was obsessed with building the most expensive, exquisite, highly specialized platforms on Earth. We built billion-dollar stealth bombers that were too precious to risk and too few in number to provide the overwhelming mass required for a major theater war. We allowed our adversaries to dictate the terms of the engagement, building massive anti-aircraft shields designed specifically to counter our predictable, centralized bomber fleet. Rapid Dragon shatters that paradigm. It proves that innovation does not always require a 20-year procurement cycle and $1 trillion budget. Sometimes, innovation is simply realizing that you already possess the largest, most capable fleet of heavy-lift aircraft in the history of aviation, and all you need is a smart wooden pallet and some parachutes to turn them into an armada of flying missile cruisers. The deployment of Rapid Dragon completely alters the calculus of deterrence in the Pacific. It solves the magazine depth crisis overnight. It provides the United States with the ability to surge thousands of stealthy, autonomous JASSM-ER cruise missiles into the theater, dropping them in massive, synchronized swarms that the Chinese Navy is mathematically incapable of defending against. It forces the adversary into a paralyzing shell game, wasting their multi-million-dollar interceptors on empty cargo planes, and it disperses the American strike capability across thousands of untrackable dirt strips, rendering the Chinese ballistic missile arsenal largely irrelevant. The era of the bomber monopoly is over. The logistics fleet has entered the chat, and they have brought the swarm with them. When the Chinese radar operators look at the skies over the Pacific in the 2020s, they will no longer just be scanning the horizon for the sleek, bat-winged silhouette of the B-2 stealth bomber. They will be staring in terror at every single slow, lumbering cargo plane that crosses their screen, knowing that the most devastating strike of the war might not come from a fighter jet, but from a steel cage rolling off the back ramp of a moving van. Thanks for watching Doctrine of War. Do you believe that Project Rapid Dragon is enough to overcome the massive numerical advantage of the Chinese Navy, or does the US still desperately need to accelerate the production of the B-21 stealth bomber to hold the line in the Pacific? Let us know your tactical assessment in the comments below. Stay sharp, stay relentless, and we'll see you in the next one.